Hi everyone, today we're going to be looking at the Productivity PLC Node-RED MQTT. Now we will be using an MQTT broker in Node-RED to communicate to the Productivity PLC clients. MQTT stands for Message Queuing Telemetric Transport. This simple publish and subscribe communication protocol does not take too many resources. Constrained devices with low bandwidth are ideal for MQTT. This protocol provides machine-to-machine or M2M connectivity, perfect for the Internet of Things or IoT. This protocol is not for remote I/O or real-time deterministic applications. MQTT is a good solution for applications that move data from hundreds or thousands of machine sensors to clients in many networks. We will be installing and programming the AEDES MQTT broker in Node-RED, that's AEDES. A Productivity 2000 and a P1000, and Node-RED will be the clients communicating to the broker. The PLC simulator inputs on each controller will control the outputs on the other controller. This will be demonstrate the communication capability for publishing and subscribing to this IoT platform. Let's get started. Detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So what is MQTT? Now, invented in 1999 by engineers Andy Stanford Clark and Aaron Nipper, the MQTT communication protocol has become the leader in IIoT communication, which is the Internet of Things. This Ethernet communication has the following features that make it the leader with the Internet of Things. It has report by exception protocol. Information can be published when changes occur. This means less traffic on your communication network. It is a stateful protocol. You always know when you are connected or who is connected and the way they're connected. You will know if the information is valid or not. So you know when they're not connected as well. So it's a lightweight protocol. So you have small payloads of binary data that will simplify the network and make it more robust. And it's flexible. MQTT brokers can be expanded easily to create more extensive, robust networks. So the MQTT system configuration. So as mentioned, the MQTT uses a publish and subscribe protocol. The client or device on the network can subscribe or read or publish or write to a broker. The broker's primary job is to control the namespace of the network. When new data is published, it will update the value and send out the information to all that have subscribed to that value. In our system, we will have the inputs of the Productivity 1000 and 2000 PLCs published to the MQTT broker. Then the P1000 and 2000 will subscribe to the published inputs of the other controller and update the outputs. Now the MQTT unified namespace. A unified namespace is a central location in the system with data, information, and contents. All contents are available for any device or application to consume or publish for the subscribed application. The namespace will organize into logical groups for your system. This makes the content easier to find and manage as the system grows. Okay. So here are the parameters of our MQTT broker that we will have, and you plan your information for the network. Think about it in logical steps. So here we have the productivity, we have the machine, which is the P1000 or 2000, and then we have our simulator inputs, and then we have our payloads, which will be P1 inputs and P2 inputs. Now we don't have to prearrange to set all these parameters up. Once the information is set in the broker, it will be understood by the namespace. So basically here what we're doing is we're taking the inputs here of our P1000 and we're writing them to the output here. Then we're taking the simulated inputs from our P2000 and we're writing it to this output here. So that is what our program is going to be doing. Next, what we'll do is we're going to look at the broker on our Node-RED, and the Node-RED will be actually running on our Raspberry Pi. So if we call up our here we go, our VNC viewer, we are connected to our Raspberry Pi right now, and you can see we are using Chromium to actually call up and run Node-RED locally here on the system. And the first thing we will do is actually look at our Node-RED itself and look at the IP addresses that we have. So we call up a terminal, and in that terminal, if we type in ifconfig, this will call up our Ethernet unit here, which is our connected Ethernet module, and we have an IP address of 192.168.1.134. We also have a Wi-Fi network here that's already set up, and we have an IP address of 192.168.1.133. So that is the one we're going to be using. We're going to do remote, so we're going to do wireless to our productivity PLCs. So going back to our, close this down, our Chromium, what we will do is we will install the 80s broker. Now we already have it installed here, but if you didn't, you'd go into the main menu here, and under the managed palette, go to the install, and if you type in the 80s, AEDES, here is where you would then install it, and that would say install, and you just plus that or click that button. So we have that installed already, and it's actually installed under our network right here, and down here you will actually see the broker itself. Now looking at the broker settings, what you'll see here is that we have our MQTT port, which is 1883, which is the default, and we also have our WS port 8080. And that's pretty much everything that you have to do to actually have this broker up and running. Now this broker is really good for your home automation and quick testing of your devices. Is it done there? And you can see here that here's our 80s MQTT broker, and we've actually added some payloads here to actually monitor the data coming from our broker itself. Then what we've done is we have our subscription. So what we do under the network is we use the MQTT in to subscribe, which is what we've done to our P2 inputs and our P1 inputs. So let's look at our P2 inputs. And you can see here, again, the server is going to be the local under port 1883. The topic will be our namespace, which is productivity P2000 sim inputs. And then our actual name will be P2 inputs. That's what we're subscribing to, and it's going to automatically detect a string in this. So, and then we have our P1 inputs. And again, just like our names space said, there's our local network, our productivity P1000 and sim inputs, and our actual name is P1 inputs. And then we have a quality of service, and quality of service can be 0, 1, or 2. 0 means it will send out information. Number 1 will basically have an acknowledge back saying I got the information. And quality of service number 2, which says that I got the information, it's only happened once. So there's a lot more communication with the quality of service number 2. So that is our program, and what we do is we just deploy that program, and it will send that to our Raspberry Pi. And then next what we'll do is we will actually take a look at our Productivity 2000 and our client for the Productivity 2000. So we'll just call up our productivity software, and here it is right here. And we are currently online and connected to this controller. And the first thing we will do is take a look at our hardware configuration. And under the hardware configuration, you will see that we have MQTT located right here. Now the first thing we need to do is actually ensure that we are on the network, that which we are, and we're connected, which we are as well. So that's involving your setting your IP addresses. So if you look under MQTT, what we would do is we didn't have anything here, we would drag this MQTT client over. And the productivity line of controllers could only be an MQTT client. Calling this up, what you will see is that we have our device name. This is MQTT P2000. This is what the device name will be on the network itself. And then we have our use structure. We'll have an MQTT structure, which then sets our connect, error code, and enable. We're going to use the specific address. This is 192.168.1.133, which you'll remember actually came from our Wi-Fi itself. And then we have our TCP port 1883. This is the default for MQTT. And our time keep alive is going to be 30 seconds. So this means every 30 seconds, it just makes sure that everything is okay and still active client. Then what we have is down here, we have a subscriber and we have a publisher. And to get those, you just hit the plus sign and you can see both of them. Now, on a client, you must have one or the other, or both, as I do in my case here. So under the subscriber, our broker topic, again, is going to be the same namespace as we had before, Productivity P1000, simulator inputs, and then our payload is P1 inputs. And we also have a receive counter, P1 input count. So that is how we set that all up. And then if we move down here, you'll also see that we can have actually 10 of these topics themselves. So we can have 10 subscribed on our system. We can also hit our monitor, and our monitor, what it will do is monitor this MQTT client. So we already have that listed right here. So we'll just hit cancel and then we hit OK. So that is our client set up for our Productivity 2000. Now looking at the program, close that down, you will see that we have our display screen, and we have we're going to extract the string. First of all, there's our display page. In the first line, we'll just have some scrolling messages. And that simple timer here is just going to control the rate at which that scrolls across the screen. Line 2, we'll just say MQTT, IoT, Internet of Things. Then line 3 will have our P2 inputs. And line 4 will have our P1 inputs. So line 4, what we do is we will enable our structure. We will enable our publisher and our subscriber. Then in order to have our inputs, we want to pack our string. So we're going to take our inputs here and we're going to pack them and put them in P1 or P2 inputs so that our MQTT can then publish them. Then we have an unpack. So we're going to take our P1 inputs that we subscribe to coming back in, and we're going to actually break them up and put them into an output channel to set those output bits. So that is our entire program. So that was our client on our Productivity 2000. And next we'll have our client on our Productivity 1000 controller. And here we are again. We are connected to this unit. And then once again, what we'll do is go into our hardware configuration. We'll go into the MQTT. We can actually then look at our device name. Again, we call this MQTT P1000. Remember, the device name has to be unique on the network itself. We're using the same structure, and then we're using the same IP address as our broker, so the broker is going to be the exact same. Under the subscriber here, we have our broker topic. Again, we're going to now ask for the P2000 simulator inputs and the P2 inputs themselves. And we have, again, the P2 input count. If we look at our publisher, you can see that we have our publisher topic and our publisher input, which are P1 inputs. Notice the publishing rate we have at 1 second. So every 1 second is going to be publishing this information out to the system in order to update, have the broker update all the other clients on it. So that is our publish and subscribe. You also notice that we also can set our last will and testament. This basically means if we no longer have it, this will take, or what the information will be as we send it out. So in our case here, if we wanted to be all zeros, once that device disconnects, we would set our last will and make the payload all 0. So very powerful. And again, this is MQTT, very adaptable. You can see here, I don't have to prearrange anything. It's automatically set up for me and I just start using it. And down here at the monitor, we can hit monitor. Again, we already have one here to monitor in our data view. So we're good. And we just hit OK. So that is our MQTT in our Productivity 1000 PLC. And if we look at the program, again, we have 3 lines in our program here. We have our enable, so we enable our structure for MQTT to actually work. Then we have our MQTT publish enabled and our subscribe enabled. Then what we do is we pack our strings. So we take our input simulator and we pack them into the P1 inputs tag name. Then we have our unpack string. We take their P2 inputs and then we fire our inputs directly from it. So it's actually taking our ASCII string and converting it and putting it into a binary string. So now what we can do is we can actually look at our hardware. We have everything actually running. So looking at our hardware, we can see that we have our P1000 right here. Then we have our P2000 right here. We have our scrolling message across the screen that we've just talked about. And we have our Node-RED running on our Raspberry Pi located right here. And that Raspberry Pi has the broker as well as it's subscribing to some clients. So if we, first of all, we're still monitoring our P1000. So on our P1000, you can see that if I turn on the bit, you can see how we pack that string here. And then we, if we turn on the first one here, you'll see that it turns on the first output. So it takes the P2000 and unpacks it. Run the first 3, and you'll see those first 3 actually turn on. We can also see this in our data view. So if we go to Tools, Data View, and here is the data view for the Productivity 1000. And you can see which is on and which is off. Let's turn them all on, and you can see they're all on. Now let's go to our P2000. And again, we can see that our P1000 inputs are all on. We have those set. We can actually turn the first one off, and you'll see that one's off. Then we have our data view we can monitor. In our data view, you can actually physically see our inputs, our client, and what's happening here. So then What we also do is take a look at our broker. So here we go with our broker, and what you see is we have our debug, and we can just clear those messages, and we can actually now take a look at our P2 inputs. So our P2 inputs just look like this. Remember, it's publishing every second. So if we turn off or turn on, let's turn on the rest of them there. What you'll see is that if we hit the monitor again, you can see them actually all on. Or turn the first three off, and again, first three are off. We'll delete those. We'll actually monitor our P1 inputs, and you can see all but the first one. So let's just turn them off, and you can actually see the update time as we go ahead and do that. Turn the first one back on. So you can see how our debug node on our message payload can actually be used to monitor what's actually happening. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is posted every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.